Hello and welcome to the recording of the Great Basin water supply briefing for March of 2016. My name is Greg Smith. I'm a senior hydrologist here at the River Forecast Center. A little bit of information first about the water supply briefings and their intent. They're meant to provide information about the hydrologic conditions, and in this case for the Great Basin, and how these conditions are impacting and are represented in our hydrologic model from which we provide water supply forecasts. These briefings are also meant to provide some information on how accurate the water supply forecasts are at various points in the season, and also other impacts or considerations that are taken into account that may affect the water supply forecasts are discussed. This is the first time we've done the Great Basin specifically. The intent here is to allow us to better focus on the forecast areas of the Bear, Weber, Six Creeks, and Provo, Utah Lake areas. Previously, this was combined with a Colorado River Basin water supply briefing, but we found that we just weren't able to spend enough time in each area. We are still having that Colorado River Basin briefing separately, and we'll continue to have an individual Great Basin water supply briefing throughout the rest of this season. Also, I wanted to point out if there is interest in adding the Severe River Basin, that is a possibility. So there are several questions that we'd like to answer with this briefing for March. The first one is that the runoff forecasts seem quite low compared to the snow conditions. This has actually been occurring since the January 1st forecast. So we would like to get into explain why that is the case. Also, February was very warm and very dry, and there were some consequences to that when it comes to the water supply outlook, and we'll discuss that. Then we'll get into the actual forecasts and talk about the guidance for the four forecast areas. We will look at the chances for average runoff conditions this year, and we will also, as I mentioned, discuss how good the forecasts are in early March. El Niño has been a big issue this year, so we'll discuss what happened with that and what's next. The weather pattern has been changing here in early March. We'll discuss what that means for us and then get into the longer range outlook. The first thing, I'd like to review the fall temperature and precipitation. So the map on the left shows the October through November precipitation, and the Great Basin area is circled. And as you can see, a lot of this area is below average. A lot of the area is significantly below average, down in the 50 to 70% of average range. And at the same time, temperatures in October were quite warm. The problem with this is that typically at the higher elevations, and these would be elevations above about 10,000 feet, we are usually receiving snow in the high elevations in October. This year, that really wasn't the case. So at the highest elevations that contribute to runoff, we feel that the snow conditions are kind of lagging behind lower elevations. And this is represented in our model, and I'll show you that momentarily. The other issue is soil moisture entering the winter. This dry weather acted to further dry out soil conditions that were already dry, and that also impacts the water supply forecasts. So this is an image of soil moisture conditions as represented by our hydrologic model in late fall. These don't really change much over the winter. Once the snow accumulation starts on these soil moisture conditions remain fairly permanent under the snowpack until the snow begins melting in the spring. So this does have an impact in the runoff and the water supply forecast that we provide. And you can see by the image on the left, this is a blow up of the Great Basin, that the soil moisture conditions, are quite a bit below average. The only areas that seem to be showing near average are parts of the Bear River Basin up in Idaho, a little bit of the Logan River Basin, but throughout much of the Great Basin, the Weber, the Provo, Six Creeks, and most of the Bear conditions are quite low. The other issue I mentioned was the high elevation snowpack. And so on the right-hand side of this image, the Big Cottonwood and Little Cottonwood Canyon are shown. These are the two large basins just east of Salt Lake City. And the snow, as represented in our hydrologic model, is displayed. And you can see around the edges, which is the higher elevation areas of both the Big and Little Cottonwood Canyon, that the snow water equivalent values are quite a bit below average. Yet if you look at the highest SNOTEL sites in those basins, which are at lower elevations, the black arrows indicate the same period, late December. that the snow conditions really weren't so bad. They were pretty close to normal. So we've seen this fairly widespread throughout the West, especially in Colorado and parts of the Uinta Range where elevations are a little bit higher. It may not be as prevalent or predominant out throughout northern Utah, but those higher elevations that do contribute significantly to runoff, our model is suggesting that the snowpack may not be as good as some of the lower elevation SNOTELs might suggest. Then we get into the winter months where we had a pretty good December and a pretty good January. Near or above average precipitation, but that gave way to very dry conditions in February, and we'll see the results of what that has done to the water supply forecasts. The February weather pattern, there were really actually only about 2 storm systems that contributed precipitation to the Great Basin. The first one was around February 1st. That first week we had a pretty good storm system move through the west, and precipitation was widespread over the Intermountain region. And the next one was about the middle of the month, around the 18th, that brought a good dose of precipitation into the Great Basin. But outside of that, conditions were quite dry. On the right-hand side, this is a upper atmospheric pattern image, and basically the winds aloft follow along these lines fairly parallel to them. So I've got some black arrows on here indicating that. And what you can see is for the month of February, we had a ridge of high pressure. That was kind of the mean pattern that was over us. So the storms would come, encounter this ridge, and they would weaken significantly. Many times they would skirt by further to the north, and we did get a little further precipitation further up into the north in the Green River Basin. But for the most part, many of the storms brought very minimal precipitation due to this predominant ridge of high pressure. Temperatures for the month of February were also above average, particularly or especially in areas that were outside of the inversions. Once the inversions broke in the valleys, the temperatures shot up to several degrees above average. This also posed a problem with some early snowmelt up to about 7,500 feet in parts of the northern Great Basin, and that's not something you really like to see in February. So dry and very warm conditions that really aren't conducive to a good water supply outlook. What we have here now are snowpack conditions. These are the SNOTEL sites. On the left, the February 3rd snapshot of snow sites over northern Utah, and on the right, March 6th. And you can see the change in categories. Many of these were in the 90 to 110% or better category early in February, and then once we got through the dry month, many of them had fallen anywhere from 50 to 75 or 75 to 90. And it wasn't so much a snow melt, although I did mention we had that up to about 7,500 feet. At the higher elevations, it was simply a lack of accumulation, and we felt further behind the normal for this time of year. We can see, looking at some actual individual SNOTEL plots, just kind of what happened here. These plots show the median for the year in the purple, the dates on the horizontal axis, snow water equivalent on the vertical. 2015 last season is shown in the green, and this year is shown in the blue. So starting with the upper left, Trial Lake currently at 94% of median or normal, and 74% of the peak it usually sees late in April. So what we're seeing here is if you look up at the very last few readings, how it kind of flatlined and fell below the median. It's still doing a lot better than last year, but there's still quite a ways to go. The circle on the right-hand side of that graph is showing where we had the very wet spring conditions last year. So we actually did see late in May a bit of accumulation, and that also occurred down at Snowbird on the lower right-hand side. We saw that in the spring that helped. It didn't significantly enhance the runoff as much, but it did kind of give us a little bit of a buffer from the very dry conditions we had last year. So, and it also postponed some demand on the water. So there's no guarantee that's going to happen again this year, but that is just something to note. On the right-hand side, on the upper right-hand side, I have Smith and Morehouse listed. 75% of median, 71% of the peak for the season. And you can see that there were actually some melt at 7,600 feet. If you look at what's typically occurs, that's not something we see really until later in April. So it's a little disconcerting to see melt like that. That tells us the snowpack is ripening up, and as we get into periods of above average temperatures, we're likely to melt more snow off. And so there is a little bit of a concern of seeing an early melt when we see conditions like this. The other one is Tony Grove Lake on the lower left, and we're basically where we were last season at this time, with quite a ways to go. And Snowbird completely flatlined, 89% of median, but only 59% of the peak, so quite a bit needs to happen for us to reach our peak that typically occurs in early May. This is the snow as represented by the hydrologic model, and this is trimmed to areas that through our observation and calibration that we've determined to be the largest runoff contributors during the April through July period. So these are kind of the significant areas. And we can see on the left on February 1st that snow conditions in the hydrologic model really weren't too bad. Most of them were average or better in the Great Basin. So what was really holding the forecast down on February 1st was the dry soil moisture conditions. Well, now fast forward to March 6th on the right-hand side, and you can see in the model where the snow conditions have now taken a downward turn, and we're further and further behind where we should be. Only a few areas in parts of the Great Basin are near the average according to the model. So I'm going to bounce through the basins and starting with the Great Basin, Bear River Basin here, and take a look at those things that are impacting the water supply runoff forecasts. And this is a snapshot of the SNOTEL conditions on March 4th. Those in the green are fairly close to average in the 90 to 110% category. We can see down in the Uintas, in the upper Bear River Basin, headwaters, conditions not too far from average, and also moving up to the central part of the basin near the Blacksmith's Fork and the Logan River. Some of those SNOTEL sites don't look too bad, but again, these are sites that are a little bit, they're below some of those higher elevation sites that I indicated. Our model was showing lower snow conditions. Also now, if you take a look at further up into Idaho and parts of Wyoming, conditions tend to deteriorate as you go further north, and as well as some lower elevation areas. So here's the snow conditions. 70 to 90% of average is kind of widespread, and then near or below average throughout much of the areas that are the significant runoff areas. You'll notice that on the Blacksmith's Fork above Hiram, that conditions really don't look too bad, but as I show you the next slide, you'll see the soils are quite dry, and that's what's pulling the forecast down there. The triangles are the water supply forecast points. They're on here for reference, but also there's some information there on the table or the key, the legend to the left. You can see the categories that the water supply forecasts fall into. So here's a look at the soil moisture in the Bear River Basin, and you can see the best conditions are further north up into Idaho, but once you get into most of the other areas, the soil moisture conditions are quite poor, below average in most locations. And you can see that area just east of the Hiram, the HRM in the Blacksmith's Fork, is a very dry area. And you'll see that impact here in the water supply forecasts. The April-July percent of average volumes for the Blacksmith's Fork is about 67% of average. And for some of the lower elevations, such as the Little Bear, in that conditions are even worse. The Bear River at State Line and the headwaters up around 80% of average. The Stewart Dam stands out like a sore thumb with 44%, but that's a partially regulated forecast point. Water that's released out of Woodruff Narrows Reservoir, we don't have a real good handle on all the diversions that occur or the return flow that comes back into the river. But we do have a pretty good relationship that shows in dry years, Stewart Dam tends to come in quite a bit lower than everybody else, and in wet years it comes in a bit higher than everybody else. And so that's kind of one of the relationships we're using there for such the low forecast at Stewart Dam. In the Weber River Basin, we take a look. We see snow conditions A little bit worse than we did in the Bear. Only a couple areas on the SNOTEL sites are in the 90 to 110% category. The rest are all below average if you look at Smith and Morehouse and Chalk Creek on the lower right-hand side. The snow model, or the model representation of the snow, also shows quite a bit of area, either near or below average right now. Above Croydon, that area is, you'll see that momentarily, that's one of the lower forecast, lower runoff forecast areas. Soil moisture is pretty dry. It's a lower elevation area, and the snow conditions are all in that 70 to 90% of average category. So here's the soil moisture conditions. Again, these are driving the forecast down quite a bit throughout the River Basin as well. You can see they're fairly low in the Croydon area. A little bit better above Oakley, 70 to 90, but again, still below average throughout much of the basin. And then here are the water supply forecasts issued for March 1st, showing near 90% up at Weber at Oakley, but then quite a bit of a drop off, only 56% at Chalk Creek, very low at Lost Creek due to both low snow and dry soils, and 72% of inflow into Pineview. So conditions in the Weber River Basin, not ideal at this point in time. The Six Creeks drainage is shown here, and we're primarily focusing on these drainages or these basins east of Salt Lake City along the Wasatch Front. You can see some of the SNOTELs up there at Brighton and Snowbird, a little bit below to near average. They drop off as you move further north. There's not a lot of SNOTEL sites here we have in this area with a long period of record for us to be able to reference just yet. But we can also see the snow from the model shows that for the most part the area is quite a bit below average. Little bit of closer to average pockets up in the Parleys, Del Fork area, but for the most part these higher elevation areas are below average, or below normal, excuse me. The Six Creeks soil moisture entering the winter also is below normal quite extensively, especially as you move further north up towards Immigration and some of these lower elevation areas. Little Cottonwood Creek, not as bad as some of the other areas, and you can see that the runoff forecast there is also not as low, being impacted by the soil moisture conditions. Here's a look at the actual forecast for the Six Creeks basins for March 1st. Little Cottonwood Creek up near 80%, and then things kind of drop off as you move north of there. The lower elevation areas quite a bit lower as far as the runoff forecast compared to average. Once you start getting snow melt, these basins tend to drop off really quick. Recall this is an April through July forecast period, so if you're starting to lose some of the snow in February and or March, it's not necessarily a good thing for the April-July numbers. And then finally, we get into the Provo River, Utah Lake area, and we can see where we have the SNOTELs up in the upper Provo River Basin are indicating near or slightly below average conditions, and then throughout the rest of it, kind of in that 75 to 90% of median or normal range. Taking a look at the snow as represented in the hydrologic model, 70 to 90% is quite common, but up above Woodland things aren't as bad. Conditions up there actually show near average and a few areas slightly above average. Once again, if you push into the soil moisture though, we see that soil moisture conditions are really dry throughout this basin, and once again that is going to impact the water supply forecasts. Here's a look at these forecasts. So 73% up at Provo Woodland, inflow to Deer Creek near 70%, Utah Lake inflow overall about 60%. So forecasts again in this area are really not very good. Spanish Fork only in the mid 40%. You jump over there into the Strawberry River Basin and conditions over there aren't very well either. So this whole area could really use a dose of some wet weather over the next month or two. So I want to talk a little bit about the primary drivers of the forecast and exactly what goes into this. And this is all within the context of our hydrologic model that we run here at the Colorado Basin River Forecast Center. We have soil moisture, snow conditions, current stream flow, all represented in the model. And then we have the option of using short-term weather forecasts, 5 to 10 days out. We tend to look at about 5 days worth of precipitation forecast and 10 days worth of temperature forecast. But what do we do after that? People have asked, do you guys use the Climate Prediction Center information? What kind of information do you focus on? What we do is we use the 1981 through 2010 climatology, but we look at this on a year-to-year basis. So what I want to do is try and explain when we're sitting here on early March, and we're making a forecast, we have a lot more information in front of us than what the one number that most of the people using our forecast tend to focus on. We end up coming out with 30 different traces. And the way we do this is we start with the current conditions in the hydrologic model, and by current conditions I mean the current snow, the current soil moisture, the current stream flow. The model is simulating the current stream flow exactly. And then from this point forward, we will take the observations that happened in 1981 for temperatures and precipitation, and we'll feed that into the model from this time forward through the spring and summer. So basically we're saying, give us today's conditions, and let's go back and let's run 1981 from this point on. And we'll get a forecast trace here that you see, kind of a stream flow pattern going throughout the spring and summer months. And we'll do it with all of these 30 years that the model is calibrated on. So it gives us 30 individual stream flow scenarios based on the climate from each one of those years. The result is a table that kind of looks like this. And in the blue box, what each one of these values are, they're an actual runoff volume. And this is for the Weber Oakley. So this is saying that if I take today's conditions, but from this point forward, I'm just going to dump in what actually happened in 1981, I'm going to get a flow of about 112,000 acre feet, which is just a little below the average of 118. If I take in 1995 and run that, I'm going to get a forecast of 146,000. So 1995 was probably wet in the spring, and we built a snowpack, and that's the runoff scenario that would result if 1995 were to repeat from this point forward. So we take a look at this table, and we can see that there's actually 6 years in here of the 30 that would give us a runoff volume near the average of 118,000, well, near or above the 118,000 threshold. There's 6 scenarios in that 1981 through 2010 period of record. So 6 over 30 comes out, roughly about 20% chance based on the 81 through 2010 climatology that we use, that we would be able to recover and get average runoff. And we see that in the table on the right too. The blue box, I've kind of highlighted the 50% exceedance forecast. That's the one that we tend to put out. That's the number we tend to focus on and put out something near that as the official forecast. But there's a wide range of probabilities associated with the forecast. This is the 50% one that you're seeing, but you could look and see what a kind of a worst and best case scenario is by looking at this full range of forecasts. So we take this table on the right hand side, and one way of presenting this information is on this plot called an evolution plot. Each one of these vertical blue bars is the forecast, is an guidance from the model on a daily basis. So you can see we started doing this back in mid-November around Thanksgiving, and we update the model with current observations and new precipitation and temperature forecasts every day, and we feed this into the model. So once a storm system comes through, you can see where some of these have actually increased and some have decreased. And so what you're seeing here is that whole range of probabilities from 10 to 90%. They are indicated here in these vertical bars. The top of the bar is the 10% chance of exceeding the volume that it's indicating. The 50% is that dark middle blue dot, and that's the primary forecast. And then the 90% exceedance volume is on the lower end, saying there's a 90% chance we're going to see that. You also see how these get narrower and narrower as we get into time, because we're getting further into the season. We have more observed snow than we have guessing what's coming. So there's more confidence in the forecast as we move forward. And then the official forecasts that are issued at the first of the month are also indicated here, with the red rectangular box in the middle being the 50% forecast. The 90 and 10 are on the on the ends, and then also the 30 and 70 are those kind of inverted triangles there. So this is a way to track what the guidance is doing between official forecasts and see how it's responding to the storm systems as they move through. And I'm going to show that, again, we had a roughly 20% chance of the April-July runoff reaching the average, which is on the right-hand side highlighted by that black box. If we look at a few more of these in our forecast areas, the Logan River near Logan, for instance, representing the Bear, we see that our 50% forecast is quite a bit below average, down around 70% of average. And the 10% exceedance, which is the top of that last blue bar, that's the latest forecast on this plot, actually doesn't even get us to average. So there's a less than 10% chance, based on today's conditions in the model, how they're represented, and based on the 1981 through 2010 climate record that we're feeding in here, there's a less than 10% chance that we're going to see average runoff this year. Here, looking at the Provo River at Woodland, right near a 10% chance that we're going to see average runoff obtained. The forecast is actually down around, I said 73% of average. And Little Cottonwood Creek at Salt Lake City, again, less than 10% chance that we're going to get to average. Now, could we get to average? Certainly, but it's going to take something that is more extreme than from this point on than has really occurred in that 1981 through 2010 period. So we would need a really wet spring or really delayed melt or something to give us an efficient runoff to bring us back to receiving average. A few more slides here. This one talks about the forecast accuracy and how good the conditions are in March. It's a busy plot, but it's not really too hard to understand. On the right-hand side are the forecast points, and I've circled the Logan River at Logan there. And with each one of these points, we have an error associated with how well the model has done. We've taken the model back 30 years, and then we've looked at the actual runoff 30 years, and we've compared determined what the error is over that period. Errors will vary from year to year to year. So this is just a model. This is just the error for the month of March for the April-July forecast. What is the typical model error? And for the Logan River in March, it's about 19%. We get better in April, that's 14%. We tend to get better January through May, looking at just about every forecast point. We can see the Weber near Oakley, the March error is 17%, the April's 14%. Provo near Woodland, a little better at 16%, the April's at 13%. Big Cottonwood's on here as well, with similar March and April errors. The areas that we tend to do well in tend to be headwater areas, and you can kind of see those in the circled blue areas. Those are all headwater areas. They're primarily snowmelt basins. Other areas that may be downstream from diversions and other demands, we do okay as long as we know what those diversions are, and we can add that information back into the historical record. Areas we don't do very well in are lower elevations where we may have early melt that occurs on various years, or we may have rain that is a large part of the runoff during the April-July. Downstream of diversions and irrigations, if there's a lot of them, and especially if we don't know much about those irrigations or the diversions. And so areas in kind of the greens to dark blues are kind of where we want to be, and areas in the oranges and reds are where we continuously are trying to improve our model. The other thing that you need to also realize is where is the forecast. So just because there's a model error of 19%, you know, that may be on the Logan River there, that may be pushed or influenced by just 2 or 3 outlying years. 2011 was a big year where we had a large observed volume, and we under forecast that. 1997 was another year with a large error, 99. So if we get those 3 years out of there, our error probably drops quite a bit. The orange vertical arrow shows the current forecast of 79,000 acre-feet, and you can kind of see where that's grouped. We tend to do pretty good in that forecast range, so we don't tend to have big errors in these kind of dry to just below average years, unless something extreme happens in the spring. So next up, just a couple more slides. I want to talk about El Niño. Keep in mind, if you recall, it's characterized by unusually warm temperatures in the Pacific Ocean near the equator. It impacts the jet stream strength and location, and therefore the storm tracks. This El Niño was particularly strong. If it does not go down as the strongest, it will go down as one of the strongest, with the other 2 years listed there. The impacts tend to be a strong southern jet stream. It tends to increase precipitation over the southern tier of the United States. Warmer, drier conditions are more common over the north, and the primary impact periods follow the peak, which occurred in late November this year, so it's usually in the December through March period that you see the largest impacts from a El Niño event. This is kind of a interesting little chart. It shows the average El Niño winter conditions in the north, and the red arrow is basically the placement of the strongest jet stream. And so what we see here is that's kind of displaced further south towards Southern California and over the southern third of the country, where it brings typically lots of tropical moisture into the region. Well, on the lower frame, you can see that jet stream, the intensity of it's a little more diffuse, and it's also placed further north. So it's one of these situations that didn't really result in it didn't play out the way we normally expect it to play out. And what this suggests is simply we just don't know everything. We know a lot about El Niño, but there's a lot of things in the atmosphere and the ocean-atmosphere interaction that we're still figuring out. We tend to not mention El Niño all that much when it comes to the Great Basin, because we sit in this in-between zone between the warm and dry. We've had wet years during El Niños, and we've had dry years during El Niños. So in our analysis, we've not shown it to be a strong correlator, a strong indicator of exactly what kind of runoff year we're going to have. So El Niño has been weakening over the past month, and it is heading towards a neutral condition, which we should see by the May, June, July period. And then a lot of forecast models, and that's what these lines are, various forecast models, are indicating that we may go into a La Niña condition, which is a cooling of the waters near the equatorial Pacific. That tends to mean drier and warmer conditions to the south. It's a flip-flop, drier, warmer conditions in the southern part of the country and cooler, wetter conditions in the north. At times, some of that cooler, wetter conditions does push down into the Green River Basin of Utah, maybe the Bear River of Idaho, maybe parts of northern Utah. So that's definitely something to watch for next winter as we get headed in that direction. So this was presented on Monday the 7th, and there was a storm system indicated by the number 1 there that was moving through the area on Sunday the 6th, moved through the area during Monday the 7th and into Tuesday. And it did bring some additional snow accumulation. It did make the snow numbers look slightly better. Once again, March is a wet month, so we expect to see quite a few of these storms come through just to reach average for the month. Storm system number 2 was moving south, affecting primarily southern Arizona and northern Mexico, with not a lot of impacts for our area. A midweek storm was expected to come by in the Tuesday-Wednesday time frame. As we see, this is actually an output from the weather model, and what it shows in the areas that are have some of the shading. This is precipitation areas, and the other areas are basically the wind flow pattern in the atmosphere, 500 millibar level. And so it shows a system that's kind of moving into the area, brushing northern Utah and the Bear River Basin midweek. And then by the weekend, another system is moving through. The models are back and forth and all over with this, but it suggests maybe by later Saturday and the Sunday, another weak system may brush by the area, but it probably would not be a really large precipitation producer. And the next one would be in the middle of March, so right around NCAA tournament time, where that's starting. A very large and kind of elongated trough develops over the west. The details, the devil's in the details on how this is going to progress, but and it's a little bit lower confidence because it's a little bit further out, but there is a potential for widespread precipitation with this system, so it's a keep your fingers crossed kind of system that if this works out, this could be a little bit of boon to and just what the doctor ordered for the snowpack and bringing us some precipitation during the middle part of the month. This is the outlook for March from the Climate Prediction Center. It doesn't really show us much on the left-hand side as far as precipitation chances over the Great Basin areas we've been talking about, kind of equal chances. On the right-hand side, though, it does suggest overall that we'll have warmer than average temperatures. There's an enhanced probability of that. On the March through May outlook, shows there's a little bit better chance for above average precipitation over the Great Basin. The percentages are still low, but it does indicate that perhaps the chances are a little bit better that we'll see precipitation above average in that period, and also continues with a warm scenario over the area during this time. So that's pretty much it for this first Great Basin water supply briefing. Just to summarize, dry soil moisture conditions, are impacting the forecast quite a bit. They're really dropping the forecast anywhere from about 5 to 15% of average. Highest elevation snowpack above 95 to 10,000 may not be as good as we think, so basins that have good runoff that come from those areas, we're thinking they may not see as good a runoff as lower elevation snow measuring sites might indicate exist. The melt has started in some areas up to 7,500 feet. This kind of increases the prospect for an earlier runoff if we're seeing energy get into the snowpack like that and bring it off in February. Cool weather could alleviate that, so we're hoping we don't get too warm too fast. It's still possible to get average runoff. Certainly it's always possible, but I would say it's not all that likely unless we get a real wet spring. The weather pattern is progressive, greater storm frequency, so that's a good sign. That's a big change from February. The question is, are the storm tracks going to come in to where they're going to be repeating over the same area of the Great Basin and helping us build that snowpack a bit more that we need to do. The water supply focal points are listed here. You're welcome to contact them at any time for information, or any of us if you'd like to discuss what we presented today. We will have some more briefings coming up. On the 10th of the month, there's a peak flow webinar. On the 7th of April, the Colorado River Basin water supply. And also on the 7th of April at 1 p.m., we'll do another Great Basin water supply. These briefings will take on their own flavor depending on what conditions are, so we may talk about something a little different. The concept will still be the same. The focus is going to be on water supply. But please join us if you've found this useful, and please feel free to share this with other interests in the Great Basin, as we're trying to let folks know that we've broken this area out and would like to focus on it more. Thank you for your time.